6.
Well, welcome back, everyone. This being our last lesson of Chapter 6. So that was a little, I guess, movie trailer somebody put together that kind of deals with what we're talking about here today with the inequalities in two triangles here in 6.6. This is from our big ideas. They had it 5.5-7, but ours is 6.6. And the Hinge theorem was on there, so it was about the Hinge theorem, about those two alligators. They both were identical as far as, they were twins, and that means that their mouths, their jaws were, exactly the same. So the bottom and the top of their mouth was exactly the same. But as you can see, one of them, I forget which one, Bob or Steve, was satisfied with just eating a little deer or whatever that was, a little guy, and then the other one was not satisfied. He wanted more, so he ate the bigger one. And so the Hinge theorem is what we talk about when we're talking about that kind of situation as far as their mouths opening to different angles. So obviously the one that ate the smaller one opened just a little bit, but the one who ate the bigger one had to open a lot more, so the angle of that gator was a lot more, which means he was allowed to eat more because the side opposite the mouth would be bigger on that gator if you opened it wider. So we'll look at that, really what that is here in a second as we get into our cartoon. Just here's a little bit of a hodgepodge of all the snowmen. So some of these I've done before, like there's the sharks, chasing the one snowman. But there's a whole bunch of different ones. You can kind of pause the video if you want to and just take a look at some of these. It's kind of fun to look around and see what they came up with for Calvin to make in the snow. All right, so I'm going to move on. And here's what the Hinge theorem is. So the Hinge theorem, the reason why they use the word hinge is because it deals with a hinge. And actually in your notes right there, right in the page on 190, it shows you a hinge. So it has this picture here. This is a picture of a hinge. This would be a hinge for like a door, like a cabinet door, where the screws would go through these little holes here on the cabinet, and then the other one would go through the door, and that would hold the door to the cabinet, and you're just opening the door back and forth then on this hinge. And so that's what a hinge is. And so what happens when you open and close a door, any door, you walk through doors every single day, you're applying the principle of this Hinge theorem. What you're doing as you're opening the door, if the door is closed, it's like the angle there at that point of the door is at 0. As soon as you open the door, that angle increases, and it continues to increase the wider you open the door. And so that's what the Hinge theorem is talking about. And so obviously, if you only open the door just a little bit, and just like a little crack, like let's say an angle of maybe 5 degrees, you're probably not going to fit through that door. You would need to open it up a little bit more than that, maybe an angle of 45 degrees, but a longer angle. That means you can fit through. And so the side there of that triangle that you would create, then you would create a triangle with the two sides there from the door, just like this hinge. These would be the sides. The third side of the triangle would be like an imaginary side or invisible side that would connect this point to this point, creating a triangle. So the bigger this angle is, the longer this side would be, and more could fit through, as we could see. So that's what the Hinge theorem is really discussing here. It gives you two triangles. You have two congruent sides, just like we have on our hinge. This side here is congruent to that side there. They're the same. So you have two congruent sides. And actually, the sides don't have to be congruent, I should say. You're going to have two triangles, what we're going to talk about. So you have two hinges, really, what you have. So two hinges that are identical. So if I had a second hinge, the sides would be the same. So I could do that right here. Here, I'll show you. I can make a second hinge real quick. There it is. Second hinge. So now you can see that the sides are exactly the same. So this side here, I'll even mark it. So that side right there is congruent to that one there. And then, of course, this one here is congruent to that one there. So you have two that are going to be congruent. These two are congruent to these two. But the angle, obviously the angle is the same on both of these because I just copied it, but the angle could be different. And so that's what we see here on our diagram with these two triangles. You have your angle here, V or XV is congruent to RT here, and then VW is congruent over here to RS. But the angles here are different. This one between these two congruent sides, between the two congruent sides is 88. This one's 35. So that means that if this was a door, more is going to fit through this one because this is going to be longer. So this side is going to be more because this angle is more. That's all it's really talking about. That's what the Hinge theorem says. So if we read through this, if two sides of one triangle are congruent to two sides of another triangle, that's the situation we have here. And the included angle of the first is larger than the included angle of the second. So here's our first one, here's our second. If this is larger than the second, then the third side of this first one is longer than the third side of the second. And that's all the Hinge theorem is saying. Now there is a converse to that, which is again reversing this. So again we have these two sides here. So CB is congruent to FE, and this AC is congruent to DF. And it shows you here this side between AB is 12 and this one here is 9. So it's going to tell you that angle C is going to be greater than angle F. That's all it is. So it sounds kind of tricky, but it really isn't that difficult at all. All right, let's do some problems here. Now we're talking about inequalities in this lesson. So that was the title of this lesson. If I go back, inequalities in two triangles. So we're going to be dealing with greater than, less than symbols, and even equal to. So greater than, less than, and equal to is what we're looking at. As you can see over here, that's what they're using. They use the greater than, or in this one also using greater than. But we're going to use greater than, or less than, or equal to. Those are the three that we're going to look at. So we can have greater than, or less than, or we can have the equal to. Those three symbols we'll use in our extra practice. All right, let's move on to that. All right, so I'm going to kind of have you do these on your own. All you need to do is figure out, are you going to use a less than, a greater than, or equal to symbol to put in this line and fill in the blank. So BC and EF, so side BC here, side EF, is BC greater than, less than, or equal to EF. That's all you got to do. And do the same thing here, greater than, less than, or equal to for all three of these. So look at your diagrams that you have there, see if you can figure out what's going to be in there. So pause the video quickly and just do that, and then play it, and I'll show you the answers. All right, so for the first one, again, we just got to look at the angles here. For this one, angle A is 35 and angle D is 45. So that means that since 35 is smaller, BC is going to be less than EF. So it's a less than. It's a less than symbol. So again, the mouth has got to open to the bigger one. So just like those alligators, the gators that we talk about with the greater than, less than, the alligator is going to eat the bigger one. So always that is remembering. He always wants more. Alligators always want more. So they're always going to eat the bigger one. Number 2, this one, we're looking at these angles. Angle A is 95, angle D is 20. So that tells you that since angle 95 is bigger, BC is bigger, obviously, than EF. I mean, you can look at that and definitely know that, but that's how you prove it because of the Hinge theorem. And so greater than, so the mouth is going to open to the BC. That's the one that's greater. And then over here, angle A, so again, we're looking at the angles between the two sides that are congruent. So it's not like we're looking at any other angles. We're looking always at between these two congruent marks. So you have a congruent side here and here, congruent sides here and here. So the angles that are in between those, like the included angles, it's a right angle there on the A and 90 on D. Well, right angles are 90 degrees, so those are equal to, so BC is equal, so that means that these side lengths we know are going to be exactly the same. They're equal to BC, it's going to equal EF. All right, moving on. Actually, no, before we move on, the reason why, it says explain your reasoning. The only thing you want to write there is because of Hinge theorem. That's all you got to write. We can do this because of the Hinge theorem. All right, so 4 through 6. I'm going to have you pause the video and do 4 through 6. It's the same idea, except now you're given sides, and so you're trying to figure out angles. It's for A and D on 4 through 6. So is angle A greater than, less than, or equal to angle D? The measure of angle A and the measure of angle D. Fill that in with a greater than, less than, or equal to for each one. Look at your diagrams and go ahead and do that, and then play it to check your work. All right, so for number 4, for angle A, so angle A, the opposite of that is BC, and for angle D, the opposite is EF. Those are congruent, so that means that if they're congruent, then right there, because those are congruent, then they're equal. So we can put equal to between that one. Number 5, we're looking at, again, opposite sides from angle A is 14 and opposite from D is 16. So we're looking at those numbers, and since 14 is less than 16 right here, so that tells you that angle A is less than angle D. So this is going to be a less than symbol. Measure of angle A is less than measure of angle D. And then for number 6, here angle A, we're looking at the number 9. For angle D, we're looking at the number 2 right there. That's between EF. And of course 9 is greater than 2. So for this one, the A is greater than D. And obviously you can notice that just from the diagram. But measure of angle A is greater than the measure of angle D. And explain your reasoning. So this is not the Hinge theorem. This would be the converse of the Hinge theorem, because you're starting with side lengths and then going to the angles. So the last 1 through 3, we started with the angles and asked about the sides. That's the Hinge theorem. The converse is when we have sides and we're asking about the angles. All right, so for 7 through 9, I'll have you do the same thing, 7 through 9. So these ones are a little bit different, so they're kind of different on each one. So go ahead and do 7 through 9, pause the video, and then play it and check your work. All right, so for number 7, AB and AC. So AB side is over here, AC is on this side. And notice that we have the congruent marks right here, and then here's a shared side. AD is equal to AD. We know that's reflexive property, so that's our second side. So there are 2 sides here, and so we can use this Hinge theorem, or the converse of the Hinge theorem. And so again, we're looking for the opposite of AD is AB. Opposite of AB is angle D, which is 145 degrees. So we're looking at that number. Opposite of AC is also kind of angle D on this side. That's 135 number. So since 145 is greater than 135, so that means AB is greater than AC. So it should be greater than on that one. AB is greater than AC. For number 8, so there's our congruent marks right there. And so we're looking at these angles, and they're both showing congruence. So that's what we're looking at right there. It's like a vertical angle situation. They are congruent. And so that tells you that AB is the same or congruent to CD. So they're equal. Their measures are equal. Those lengths are equal. And then on number 9, here's our congruent marks here on those. So we have a triangle up on top, a triangle down at the bottom. It's got a shared side right here in the middle. So that's your second one that's congruent. So angle 1 and angle 2 are the ones that are in between those congruent sides. And so angle 1 is 19 and angle 2 is 17. And actually, before I do that, let's go back here. The reason why you want to also include this, because of Hinge theorem on this one, because we started with angles and we were asking about sides. We were starting with angles and asked about sides on 8, so you can put because of Hinge theorem on that one. This one we're starting with sides, and like I said, 1 is this number 19, 2 is 17. So because and we're looking at 1 first. So because 1, which is 19, is greater than 17, that means that 1 here is bigger. 1 is greater than 2. So the measure of 1 is greater than 2 because the side opposite of 1 is greater than the side opposite of 2. And so that's going to be a greater than symbol. And again, we would put the reason why is because of the converse. We're starting with sides and asking about angles. So that's the converse of the Hinge theorem. All right, so let's move on to our joke of the day. So what do Santa's elves learn in school? What does Santa's elves learn in school? A lot of things. Geography, where the North Pole is maybe. But no, they learn the alphabet. The alphabet. Okay, so for number 10 and 11 on our extra practice, page 193, it says write a proof. And the proof, we could do a 2-column proof. I'm just going to have us write a little paragraph proof, though. That's the way that it's going to be in the answer, so I'm just going to have it we'll do it that way. So the first thing, we're going to, let's just actually look and see, what are we trying to prove? We are trying to prove that 2 angles here are not congruent, they're not equal, that this one is bigger than this one. That's what we're trying to prove. So we have a greater than symbol. We're trying to prove that this angle here, this W, YX inside here, so W, Y, X, this angle here is going to be greater than the other angle. So we're looking at this one here, WYX, that angle is greater than this angle over here, which is WYZ. So we're trying to prove that this blue angle is going to be greater than the red one. And so we're starting off, we're going to try to use this Hinge theorem eventually, that's what we'll say at the very end, with what we have to be, we're given that we had a congruent side here with XY, we're showing that on the diagram. We're also given that this side here, WX, so WX right here is greater than WZ, and as you see, WX is opposite our blue one, which we're trying to say is greater angle, and WZ is opposite the red one, which is supposed to be the smaller of the 2 angles. So we'll start off by just writing the given. That's what we're going to do. So we'll write the given for these. So I'm just going to show you what this is. So here's what we're going to say. Write down the first part and just put in parentheses given. So you're going to write this whole thing pretty much. So write the first part, given. That's this given here. Write the second one, WX is greater than WZ, given in parentheses. And now we need to say that because of this shared side, WY is congruent to WY by the reflexive property of congruence. So now what we have, we just set it up to use the Hinge theorem, because now we have 2 congruent sides of a triangle. So we have 2 sides of one triangle are congruent to 2 sides of the other triangle, or that kind of thing. 2 sides of one triangle are congruent to 2 sides of another triangle. And so that's set up for the Hinge theorem then. And we also have it set up because of this right here is greater than this side over here. So because we're talking about sides here, and we're given the sides, we're trying to find the angles. That's the converse. And so now what we would say is the prove part. So after you write the reflexive property of congruence, you don't have to write that in parentheses. That was just the number for that theorem. But as long as you just put reflexive property there of congruence, it's good. Then write down this for the prove, which is what we just have here. We're going to write the prove now, and it's by the converse of the Hinge theorem. And again, you don't have to write the little parenthesis there, but just put by converse of the Hinge theorem. And it's the converse because we were given the sides and we're finding the angles. All right, for number 11, same thing going on here. We want to see, what are we proving first? We're trying to prove sides here are congruent, or not congruent. Sides here are, one's greater than the other. DC is greater than AB. So DC, this one should be greater than AB. And what we're given is we're given some sides on the diagram, and we're given these angles here. One's greater than the other angle. So we have this, measure of DAC. So D AC. So this one right here is what we're given. So as far as what we're trying to prove that the red side here, the DC, is greater than the blue side here. And we're shown right here that this angle is the greater angle, which means that this should be the greater side. This other angle down here was the measure of ACB. That's this one down here. That's the shorter one. So we just need to do the same, pretty much same thing on this one. The only difference is that we're given the angles first and we're trying to find the sides. And so that's just going to be the Hinge theorem, not the converse. So here's what we'll write down on right below this. So write down your given again. So that's your first part, the first one there. AD is congruent to BC. That has been given to us even on the diagram. So write the given for that in parentheses. Then the measure of these angles here, measure of DAC is greater than measure of ACB. That's also given up here. That's told to us. And then we want to set it up for Hinge theorem by saying that AC is congruent to AC as a shared side. And that's by the reflexive property again. So that sets it up to use the Hinge theorem. So now that we have two sides of one triangle are congruent to two sides of another triangle, we can now use this Hinge theorem, especially when we have DC now is definitely greater, so we can prove that because of what's given to us. And so then we can just say that the proved part, DC is greater than AB by the Hinge theorem. Alright, so let's just make sure you've written down those two little paragraph proofs. That's what we call it, a paragraph proof, not a two-column proof. Okay, so problem number 12, here's our last two problems. It says, so you could try this if you have a pair of scissors there and a rubber band. It says loop a rubber band around the blade ends of a pair of scissors. Describe what happens to the rubber band as you open the scissors. How does that relate to the Hinge theorem? So I don't have a pair of scissors, but I do have a compass here. And the compass, each side of this compass is exactly the same. It's congruent. So each side, the point side and the pencil side, they're both congruent, as you can see. And so if I were to do that with a rubber band here and wrap the rubber band around this, and I start to open this compass, as you can see that right now it's at 0 degrees right here, and as I open it, the angle starts to increase. The angle continues to increase, and we can say, well, what happens? It says describe what happens to the rubber band as you open the scissors. Well, the rubber band gets stretched longer and longer and longer. The greater the degree here, the longer you're stretching the rubber band. So as we keep on going and going and going, oh man, he's doing the splits, and he's down. So obviously the rubber band, well, I guess I would lose the rubber band at that point, but as you can see, the rubber band just keeps stretching further and further if there's a rubber band around the ends of that. So here's what we could say for number 12. So you can just write this down. When the angle between the scissor blades becomes greater, the rubber band that constitutes the third side, because that would make a triangle. If a rubber band is right here, that would constitute a third side right there. And the angle that's opposite that rubber band would be right up here, and that's what the hinge is. That's where the hinge is at. That's the angle that we're moving. So as it gets wider, the rubber band stretches. So it says that rubber band that constitutes the third side of the triangle is stretched to become longer. So that's what's happening, as you can see what would happen here. So there you go. Number 13. So I can get rid of my compass now. So for number 13, it says, starting from a point 10 miles north of Crow Valley, a crow flies northeast for 5 miles. Another crow, starting from a point 10 miles south of Crow Valley, flies due west for 5 miles. So it says, which crow is further from Crow Valley? And it says, explain. Okay, so for this one, it would be helpful if you drew out this little diagram with me. So we're going to start with a point here where Crow Valley would be, and so we'll just put a dot right here, and I'll label it CV for Crow Valley. So there's Crow Valley, and then we're going to draw a kind of a line And I'll do mine over here. I'll just try to make it as possible. So this one's red. So we're going to draw a line straight up. It says north. Well, north is up from there. So north is always up, south is down. So we're going to go north right here, and that'll be 10 miles. So let's just say, a segment about that long. That's going to be 10 miles right there. So I'll label that as 10 miles right here. And that's where the crow starts off from flying. So from this point right here, so now from this point, our crow is going to fly. First crow, crow number 1, says a crow flies northeast 5 miles. So north and then east. East is to the right. So it's going to be at a 45-degree angle from here. So, I mean, I can make this perfect and get exactly a 45-degree angle. I'm going to just do my best at trying to do that without a protractor. So 45-degree angle from here. So this would be, oops, did that a little too much. Hold on, let me try this again. Get rid of that guy. And this guy now I can change. Oops, no, I don't want to do. I'll just get rid of him and start over. Alright, so let's just start over here. So I'm going to start with going here. Now I can go straight up north or straight east, but northeast is going to be about halfway in the middle. It's about a 45-degree angle, and I'll go about half of what I have there because it's 5 miles. So maybe right about there. And we'll put that point down, as that's where crow number 1 is. So crow 1 is right there. And then crow 2, he's going to be going. So let me grab this segment here. I'm going to copy that exactly and bring it down here. I'm going to change its color and now move it over here. So south now from Crow Valley, another crow starts 10 miles south, and that would be right here. So I'll do, there we go. So crow starts flying right here. And this one says that the second crow, who's starting 10 miles south of Crow Valley, flies due west. So west is to the left this way. So west is going that direction. Due west 5 miles. So I want to go 5 miles due west. So I can maybe copy this one here that I had and bring this down here and then move that exactly maybe due west. See if I can move it. There we go. So straight, kind of like that. There we go. So now that's went due west. So now what our question is which crow, so this is crow number 2. So which crow is, oh, lost my thing there. There we go. Further from Crow Valley. So because of the Hinge theorem, and we already said I should label these here. I didn't do that. So this was 5. We said down here. I'm going to change the color of this guy to blue, and this is 10 as well. So there we have these two sides are congruent. This is 5 also. So these two sides are congruent. And then if I was to attach another line here, let me do that. Different color though. Let me see. I'll do. Let's try yellow. So I go from Crow 1 back to Crow Valley, right there, and then Crow 2 back to Crow Valley there. So my yellow sides here, which one is longer? Well, because of the Hinge theorem, we know that since this right here is, this angle's obtuse, so 90 degrees would be that way. We have another 45 to add on to that. So that's actually a 135-degree angle right there. So let me write that down. This is 135 degrees for this angle. So that angle is 135 degrees. And then this angle we know is a right angle right there at 90. So because 135 is more than 90, then crow 1 is further. So here's what this is saying. You can kind of write down, as much as you want to, but you can just first start by saying the first crow. Which crow is further? Well, the first crow is further, so obviously that's what you'd put first. First crow. But why? Because it says explain. And here's why. Because 135 degrees is greater than 90. The first crow's distance from crow valley is greater than the second crow's distance by the Hinge theorem, and that's what you want to make sure you do right. The reason why is all of this by the Hinge theorem, and that's what we want to say for that. All right, so that does conclude our lesson here on 6.6, and you should be ready for your assignment there on 6.6, and I'll see you back in class.